Imagine logging into an account without knowing the password. Sounds impossible, right? But this is exactly what ethical hackers do, legally, to test and secure systems. In this full course, I will teach you how password cracking really works, from beginner to advanced level. No fluff, no theory overload, just real hacking knowledge. Hello everyone, my name is ACW360, and welcome to this complete password cracking course. If you are interested in cybersecurity, bug bounty, or ethical hacking, this video will change your understanding completely. By the end of this course, you will understand how hackers think and how systems get broken. Here's what you're going to learn in this course. First, we'll understand how passwords actually work. Then we'll move into different types of password attacks. After that, I'll show you powerful tools like Hydra, Hashcat, and John the Ripper. And finally, real-world scenarios and pro techniques used by ethical hackers. Let's start with the basics. A password is simply a secret string used to verify a user's identity. For example, when you log into a website, you enter your username and password. The system checks if your password is correct, and if it matches, you get access. But here's something very important. Websites do not store your password in plain text. Instead, they use something called hashing. Hashing converts your password into a random-looking string. For example, the password admin123 might become something like this. This is called a hash. Now you might ask, if passwords are hashed, how do hackers crack them? Good question. Hackers don't reverse the hash. Instead, they guess the password, hash it, and compare it. If it matches, they found the password. 1. Brute force attack. Brute force attack means trying every possible combination. For example, trying AA, AB, ABC, and so on until the correct password is found. This method is slow, but guaranteed if given enough time. 2. Dictionary attack. Instead of guessing randomly, hackers use a list of common passwords, like 123456, password, admin, and so on. This is much faster than brute force. 3. Credential stuffing. This attack uses leaked usernames and passwords. Hackers take data from previous breaches and try them on other websites. Because many users reuse passwords, this works very well. Now here's the scary part. Most accounts are not hacked using advanced techniques. They are hacked because of weak passwords. In the next section, I'll show you tools that hackers actually use. If you're enjoying this course so far, make sure you like this video and subscribe. Because in the next part, we'll move into real tools and start cracking passwords step by step. Let's continue. Before you try to crack any password, you need one powerful weapon, a word list. Without a good word list, even the best hacking tools will fail. A word list is simply a file that contains a list of possible passwords. Instead of guessing randomly, hackers use word lists to speed up attacks. For example, a word list might contain passwords like admin123, password, QWERTY, and thousands more. Here's a secret. Password cracking is not about tools. It's about the word list. If your word list is good, your success rate increases massively. The first tool we'll use is called Crunch. Crunch allows you to generate custom word lists based on patterns. You can install it using the command sudo apt install crunch. Let's say the target uses passwords between 6 and 8 characters and only uses letters and numbers. We can generate a word list like this: crunch 6 8 abc 1 2 3-0 wordlist.txt. This will create thousands of possible passwords automatically. As you can see, we successfully generated the target word list file named wordlist.txt. Don't generate huge word lists blindly. Always think about the target. Smart word list beats large word list. Now let's move to a more advanced tool, CeWL. CeWL creates word lists by scraping real websites. You can install it using the command sudo apt install CeWL. For example, if your target is a company website, you can extract words directly from it. CeWL-w wordlist.txt https://ginandjuice.shop. Now you have a custom word list based on the target. People often use passwords related to their environment: company name, favorite words, internal terms, and CeWL helps you capture that. Now imagine combining Crunch and CeWL. You create a smart word list and then use it with powerful tools. That's when real hacking begins. In the next part, we'll start using real attack tools, and I'll show you how to actually crack login systems step by step. This is where things get serious. Now, this is where things get real. In this section, we are no longer talking about theory. We are going to attack real login systems, just like ethical hackers do in penetration testing. An online attack means trying passwords directly on a live system. For example, a login page, SSH server, or FTP service. Instead of cracking hashes offline, we send login requests again and again until we get access. This method is powerful, but also risky. Most modern systems have protections like rate limiting, account lock, and CAPTCHA. So this only works in labs, authorized testing, or weak systems. The first tool we'll use is Hydra. Hydra is one of the most popular password cracking tools for online attacks. It supports many protocols like SSH, FTP, HTTP, and more. You can install it by typing sudo apt install Hydra. Let's start with a simple example, attacking an SSH login. We have a username and a word list. Hydra-L Mr. Robot -P wordlist.txt //192.168.240.100. Hydra will try each password from the word list until it finds the correct one. As you can see, Hydra has successfully cracked the SSH login and returned valid credentials, the username and password. -L means username. -P means password list. And // is the target protocol. Always reduce your word list size for online attacks because too many requests can trigger detection. Now let's attack a web login form. This is very common in bug bounty. Now I'm using Hydra to perform a brute force attack on a login form. I'll specify the username and a word list for passwords. And finally, I'll target the DVWA login page using an HTTP post request. Let's break down this command. -L admin, this specifies the username we are targeting. -P wordlist.txt, this is the password list Hydra will try one by one. 192.168.240.109, this is the target server. HTTP-post-form, this tells Hydra we are attacking a web login form that uses post requests. Now this part is very important. This is the login request structure. Username equals user. Hydra will replace this with the username. Password equals pass. Hydra will replace this with passwords from the word list. And finally, login failed. This is the error message Hydra uses to detect failed login attempts. If this message is not found, it means the login was successful. As soon as Hydra finds the correct password, it will stop and return valid login credentials. And boom, we get access. If there is no rate limit, no CAPTCHA, no 2FA, Hydra can break weak passwords very quickly. Now let's look at another tool. Medusa. Medusa is similar to Hydra, but sometimes faster and more flexible. You can install it by typing sudo apt install Medusa. Here, we are using Medusa to perform a brute force attack on an SSH service. -H192.168.240.100. This is the target IP address. You Mr. Robot, this specifies the username. pwordlist.txt, this is the password list Medusa will try. MSSH, this defines the service we are attacking, which is SSH. Just like Hydra, Medusa will test each password from the word list until it finds the correct one. And once the correct password is found, it returns valid login credentials. Hydra is more popular and widely used. Medusa is sometimes faster and good for parallel attacks. As a hacker, you should know both. In real bug bounty, brute force is rarely the main attack, because most websites are protected. But sometimes, developers forget to add protection, and that's where opportunity comes in. But what if the system is secure? What if brute force fails? Does that mean the account is safe? Not really. In the next part, we'll move into offline password cracking, where speed is unlimited and tools become extremely powerful. This is where beginners become professionals. What if I tell you, you can crack thousands of passwords in seconds without sending a single request to the target? Welcome to offline password cracking. Offline cracking means you already have the hashed passwords. Instead of attacking a live system, you attack the hash directly on your own machine. This makes it extremely fast and almost impossible to detect. Hashes usually come from database leaks, misconfigured backups, or vulnerabilities like SQL injection. Once you have the hashes, the real game begins. Now, let's talk about the king of password cracking, Hashcat. Hashcat uses GPU power, making it extremely fast. It supports hundreds of hash types, like MD5, SHA1, SHA256, and more. You can install it by typing sudo apt install hashcat. Let's say we have an MD5 hash. For this test, I'll generate an MD5 hash and save it into a text file using Nano. Now I'm using Hashcat to crack the hash using a dictionary attack. -M0 specifies the hash type, which is MD5. Minus a 0 means we are using a dictionary attack. Hashes.txt contains the hash we want to crack. And Wordlist.txt contains the list of possible passwords. Hashcat will take each word from the word list, hash it using MD5, and compare it with the target hash. If it matches, that means we've found the correct password. As you can see, within a few seconds, Hashcat successfully cracked the hash and revealed the password, hacked124. Use GPU whenever possible, because Hashcat becomes 10 times to 100 times faster. Hashcat also supports advanced attacks, like mask attack, rule-based attack, and hybrid attack. We'll touch more on this in the final part. Now, let's look at another powerful tool, John the Ripper. This tool is widely used for password auditing and hash cracking. You can install the jumbo version by running sudo snap install John-the Ripper. Now I'm using John the Ripper to crack an MD5 hash using a word list. -- format equals raw -MD5 . This specifies the hash type. -- word list equals wordlist.txt . This is the list of passwords John will try. Hashes.txt. This contains the hash we want to crack. John will take each word from the word list, hash it, and compare it with the target hash. If a match is found, it reveals the original password. As you can see, within a few seconds, John the Ripper successfully cracked the hash and revealed the password. John the Ripper is simple, flexible, and great for beginners and professionals. Hashcat is faster, especially with GPU. John the Ripper is easier to use and very reliable. Most professionals use both, depending on the situation. In real-world hacking, offline cracking is more dangerous than online attacks because there is no limit, no detection, no blocking. Once hashes are leaked, it's only a matter of time. But what if the password is very strong, very long, and complex? Can it still be cracked? In the next part, we'll explore Wi-Fi cracking and move deeper into real attacks. Now you understand how powerful offline cracking is. In the next section, we'll move into Wi-Fi hacking using real tools. Let's continue. Have you ever wondered, can someone actually hack a Wi-Fi password? Or is it just a myth? In this section, I'll show you how Wi-Fi security really works and how passwords can be tested by ethical hackers. Most modern Wi-Fi networks use WPA or WPA2 security. When a device connects, it performs something called a handshake. This handshake is used to verify the password without sending it directly. Here's the key idea. We don't attack the Wi-Fi directly. We capture the handshake and then crack it offline. The main tool we use for this is Aircrack-ng. It's a powerful suite used for Wi-Fi security testing. You can install it by running sudo apt install Aircrack-ng. Before you start, make sure you stop any processes that may interfere with your Wi-Fi card by using sudo airmon-ng check kill. Use this command to display the wireless interfaces available on your system. iwconfig. This command shows the wireless interfaces on your system. Copy the interface name because we will use it to enable monitor mode. On different Linux systems, the interface name may be different, such as WLAN 0 or WLP2. First, we enable monitor mode on our wireless card. This command enables monitor mode on the wireless interface. Sudo runs the command with administrator privileges. Airmon-ng is a tool used to manage wireless interfaces for monitoring. Start tells the tool to enable monitor mode. WLP2S0B1 is the name of the wireless network interface. Once monitor mode is enabled, the wireless card can capture all nearby Wi-Fi traffic instead of only the network it is connected to. This is an important step when performing wireless network analysis. Now that monitor mode is enabled, let's scan the available wireless networks. This command scans all nearby Wi-Fi networks. AeroDump-ng is a tool used to capture and display wireless network information. WLP2S0B1 is the wireless interface running in monitor mode. Now we can see available networks, including important details like the BSS ID, the channel, and the encryption type. This information helps us identify the target network we want to analyze. Now we focus on a specific target network and try to capture the handshake. This command allows us to monitor a specific Wi-Fi network and capture authentication data. Sudo runs the command with administrator privileges. Aerodump-ng is used to capture wireless network traffic. -C1 specifies the channel of the target network. -BSSID target BSSID identifies the specific access point we want to monitor. -W capture saves the captured packets into a file. WLP2S0B1 is the wireless interface in monitor mode. We focus on one target network and wait for a device to connect. When a device authenticates with the Wi-Fi, the WPA handshake can be captured. To speed things up, we can force a device to reconnect. -0 specifies a deauthentication attack. 10 is the number of deauth packets we want to send. -a BSSID identifies the target access point. WLP2S0B1 is the wireless interface used to send the packets. When the device disconnects and reconnects to the network, the handshake is captured. Once the handshake is captured, we can attempt to crack the Wi-Fi password using a word list. Now that we have captured the handshake, we can try to crack the Wi-Fi password. Here we use Aircrack-ng to attempt to recover the Wi-Fi password using a word list. Capture-01.cap is the file containing the captured handshake. -W wordlist.txt specifies the password list that Aircrack-ng will test. Aircrack-ng will test each password from the word list against the captured handshake. If a password matches, it means we've found the correct Wi-Fi password. As you can see, we have successfully cracked the handshake and recovered the Wi-Fi password. Hacked 1, 2, 3. Aircrack-ng tested over 5,001 passwords in just 5 seconds. Because the handshake contains enough data to verify if a password guess is correct. If the password is strong and your word list is weak, you will fail. Again, word list is everything. Modern Wi-Fi security is strong, so this attack only works if the password is weak or predictable. Now we've seen online attacks, offline cracking, and even Wi-Fi testing. But what separates a beginner from a professional is advanced techniques. In the final part, I'll show you advanced password cracking techniques and real-world strategies used in bug bounty. This is where everything comes together. So far, you've learned how passwords work. You've used real tools. You've seen online attacks, offline cracking, and even Wi-Fi testing. But now, I'm going to show you what separates beginners from professionals. A beginner uses tools. A professional understands strategy. Because tools alone don't hack systems. Thinking does. Instead of using a plain word list, we can modify it using rules. This allows us to generate many password variations automatically. Here we are, using Hashcat with a rule file to make the attack more powerful. -M0 specifies the hash type, which is MD5. minus a 0 means we are performing a dictionary attack. Hashes.txt contains the hash we want to crack. Wordlist.txt contains the base list of possible passwords. -R best64.rule tells Hashcat to apply a rule file that generates password variations. Hashcat will take each word from the word list and apply different rule-based modifications. For example, it may add numbers, add symbols, or change uppercase and lowercase letters. This significantly increases the chances of finding the correct password. Sometimes, you may already know part of the password. For example, the password might start with admin followed by some numbers. Here we are using Hashcat's mask attack to generate password combinations. -M0 specifies the hash type, which is MD5. -3 tells Hashcat to perform a mask attack. Hashes.txt contains the hash we want to crack. Admin $D?D?D?D defines the password pattern we want Hashcat to try. $D represents a digit from 0 to 9. So Hashcat will try combinations like admin 0000, admin 1234, admin 9999, and many others. This method is very powerful when we already know part of the password structure. Another powerful technique is called a hybrid attack. This combines a word list with brute force patterns. Here we are using Hashcat to combine words from a word list with additional characters. -M0 specifies the hash type, which is MD5. -6 tells Hashcat to perform a hybrid attack. Hashes.txt contains the hash we want to crack. Wordlist.txt contains the base list of possible passwords. $D adds 2 digits to the end of each word. Hashcat takes each word from the word list and then appends number combinations to it. For example, if the word is password, Hashcat will try variations like password 01, password 22, password 99, and many more. This technique is useful because many users add numbers to the end of their passwords. Here's the truth most beginners don't know. Password cracking is not the main way hackers get access, because modern systems have rate limiting, CAPTCHA, 2FA. They look for logic flaws, authentication bypass, token leaks, misconfigurations, in bug bounty. You don't just attack passwords, you attack the system logic. Password reset flaws, token reuse, missing verification. Always remember, the goal is not to break passwords. The goal is to understand how systems fail. If you made it this far, you're no longer a beginner. You now understand how password cracking really works. From basic concepts, to advanced techniques, to real-world hacker mindset. But this is just the beginning. Cybersecurity is a deep field. And the more you learn, the more powerful you become. If you enjoyed this course, make sure you like, subscribe, and share it with others. Because knowledge is power. And I'll see you in the next one.